station, this is Houston. Are you ready for the event?
Station's ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
And station has you loud and clear. How me?
Please stand by for opening remarks.
Hi, I'm Ken Luchin, Dean of the College of Engineering here at Boston University. Thank you, Crew 4 members, for giving us your time today. You have a room full of students from the Boston area who take part in the Calculus Project, the Alexander Twilight Academy, Upward Bound, and other summer outreach programs, all advancing broader interest and participation in science and engineering. They and their teachers are here together with a large group of students, faculty, and staff from Boston University and Boston University Academy, all celebrating your accomplishments and ready to learn more about your job and life in space. At BU, we are exceptionally proud to have engineering alumnus astronaut Bob Hines on the space station and so many other alumni in the space industry making space exploration possible. We are grateful for this phenomenal opportunity to hear from you today. Let's go to our first question.
Hi, my name is Sadia, and I participate in Boston University's Upward Bound program. My question is, why did you become an astronaut, and what were you doing before you became an astronaut?
Well, hi. It's really an honor to get to talk with everybody today. Obviously, I'm Bob Hines, and this is my crewmate Samantha Cristoforetti from the European Space Agency. So it's an honor to get to talk with you guys and see everybody in the Boston area. And I'm sporting my my best Boston attire. Prior to being selected as an astronaut in 2017, I was in the Air Force as a fighter pilot and a test pilot, and I did that for about 17 or 18 years before being selected as an astronaut. And it was really, for me, just kind of that next step. I loved the adventure of doing new things and doing things that are hard. And so going out and going after something like this, it's just such an amazing experience. And to be part of NASA and ESA and all of our international partnerships as NASA pivots towards the moon and eventually to Mars has just really been an awesome experience so far.
Hi, my name is Corey. I'm an 8th grader from Alexander Twilight Academy. My question is, how do you drink liquid since it floats?
Hey, thanks, Corey. That's a great question, and it is actually one of the cooler things we get to do. So for an example, most of our drinks come in little bags like this, but sometimes, so you can drink them out of a straw, but you can get a little more fun with it, too. And Samantha's going to help me out here. It can also turn into a disaster really quick, so, so we're ready to go. Here you go. So you squeeze the water out, and you get these little bubbles of water. So you can get small ones like that, or you can end up with a bigger bubble. Nice. There you go. Good job. Which is more water than it looks like, so it's always an entertaining thing to try and manage something like this.
Good job.
Disaster avoided.
Hi, my name is Zach. I'm in 9th grade and I participate in the Calculus Project. Can you tell me, what are the necessary qualifications to become an astronaut? Is there a specific level of math or science that you need to qualify to become one?
Hey, that's a really good question, and especially for someone young like yourself that's looking at at what you want to do for your future. So my advice, first of all, is to find something that you really enjoy and go pursue that. In order to be an astronaut with NASA, you have to have a degree in a STEM career field, so science, technology, engineering, or math, and you have to have a master's degree in one of those fields. If some of you are looking or interested in being teachers, or if your teachers are here as well, that is also qualifying experience for as long as you're a teacher in a STEM type of field. So that is a possibility, and then obviously being a U.S. citizen for NASA astronauts. But like Samantha here, she's part of the European Space Agency, and we also have our international partners with JAXA and other countries around the world that have their own specific requirements. So if there's any international students out there, don't think that that's the only way. As Samantha is a great example of being able to achieve those dreams regardless of where you come from.
Hi, my name is Victoria, and I recently graduated from Boston University with a degree in mechanical engineering. I'm curious if you would get as dizzy as you would on Earth if you did multiple flips or spins.
All right, I think we might have to give it a try and see what happens. Let's try it. All right, Bob, are you dizzy?
Yes. So the answer is yes. It is a different kind of dizzy without the gravity in there. To me, it seems like it lasts a little bit longer and it can get going a little bit faster. But it's worth it. Sometimes we'll play around and we'll just start doing lots and lots of flips together and just kind of see how many we can do without touching something. But yeah, you definitely get dizzy up here.
Hi, my name is Ibrahim. I am a 7th grader at Alexander Twilight Academy. I would like to know, do you get taller in space?
Hey, Ibrahim. Actually, as a matter of fact, you do. You know, your spine, where you are on the ground, it kind of gets compressed, right? Your spine is made of vertebra, and then in between there's like discs that are like softer material, a softer tissue. And when you're on the ground, your weight compresses your spine. And so up here in space, because we're weightless, that doesn't happen. And so those discs can kind of expand, and our spine stretches out, and we become a little bit taller. However, when we get back to Earth, all that reverts back to normal, and we get back to our normal height.
Hi, my name is Nico, and I'm in the 11th grade participating in the calculus project. My question is, what type of food do you eat, and how is it prepared? Do you have a favorite?
Hey, Nico, I love your shirt. Yeah, so we have all different kinds of food. We have an entire food lab and a set of nutritionists that kind of put a menu together that we get to choose from. And so we have a whole wall full of food that we get to choose from. So I brought a couple examples along. They come in two different categories. One is rehydratable. So it's things like this. This is sweet and sour chicken. And if you can see, it's pretty hard. Right now, it's had all the water removed out of it. And so we have a machine, a potable water dispenser, that we plug this in, we tell it how much water we want, and it'll insert water into it. And we let it sit for 10 or 15 minutes, and then it's good to eat, and it's just like new. We also have some food that go ahead. Like this, that is soup, basically. So this is a type of pouch that we can just put into an oven, and we just have a small food warmer that holds the food up against hot plates, and it gradually warms the food there. So we've got a lot of different kinds of things. I think maybe my favorite might be lasagna up here. Most of the foods I really crave from back home, like pizza and big hoagies or subs, we don't really get those up here because they make a big giant mess. So I'm craving those for when I get home.
Hi, my name is Timmy, and I'm an 8th grader at Alexander Twilight Academy. My question is, what do you do in your free time? Can you play board games?
Hey, yeah, that's an interesting question. Board games. I don't think I've ever seen any in space. They would have to be when you put things down up here, they obviously float. So you would have to do something that's either magnetic or has some Velcro or some way to put the pieces on the board and have them stay there. But yeah, it's kind of cool. I mean, we should probably come up with some space version of a board game. But yeah, what do we do in our free time? We like to hang out, have dinners or meals together and just have fun together. We watch a movie all together once a week. And then, of course, we have a magnificent view out of the window that we all enjoy. We enjoy taking pictures and videos to be able to share with everyone on Earth what we are fortunate enough to be able to see up here. And then, of course, we can call our families and our friends and chat with them.
Hi, my name is Rohan, and I'm a senior at Boston University Academy. I would like to know, what personal items are you allowed to bring with you to the space station? Do you have a favorite?
Yeah, that is something, we're up here for 6 months or so, and so we're away from our families, and I think something that all of us bring along are pictures from back home. So that is certainly my favorite. I have pictures of my wife and my kids and my parents and grandparents, and they're up on the wall in my crew quarters where we sleep. We also get the opportunity to bring things like shirts or things like that we want to wear while we're up here. So a lot of them are just reminders of home. So those are kind of the personal items that most of us bring when we're up here.
Hi, my name is Rose, and I'm a sophomore at Boston University Academy. I would like to know, what is the most unexpected challenge you have encountered while in space or while preparing to go to space?
That's a really good question and really makes me think. Our training is so amazing that there's not a lot that's really unexpected. We have simulators and mock-ups back in Houston and around the world, in Europe and Japan, that are very, very realistic. And so when you come up here, everything looks a lot like what it did on the ground. And so there aren't a lot of unexpected things other than the sensations, the physiological things that we all deal with as we adapt. So I had a headache for the first couple days up here because of a fluid shift. You don't have gravity pulling fluids down in your body. And so, I end up with more fluid in your head, and I ended up with some headaches for a couple days. That being said, I would say the biggest surprise was, one, the experience of launch and how amazing and incredible that was, and then going and looking out the window. Even though you see high-definition camera footage that shows space from the outside of the space station, it does not do it justice. The colors, the breadth of colors, and just the brilliance of everything is absolutely spectacular, and that was probably my biggest surprise.
Hi. My name is Nye, and I'm a sophomore at Boston University Academy. I know the space station has a ton of equipment and a method for storing things, but how often do you find completely random things in random places?
So that actually happens all the time. Oh, look, hey, here's our food from earlier. So. Yeah, it happens all the time. There is 0G up here, so usually if you leave something, you would think that it stays there. But there are also a bunch of air currents because of the way the air gets moved around through space station. So sometimes you take something like this and you put it there, and you turn around and do something else and come back, and it'll be gone. Or you lose something, and you come back, or you just completely just give up and say it's lost, and you might find it 2 weeks, a month later, it'll just come floating by because it got dislodged from whatever it happened to bump up against. So it is actually one of the funnier things that happens up here is, you're working on something and all of a sudden you find a pair of eyeglasses or something else that someone has lost. And, it's pretty reliable, actually, is if you just wait on it, it'll reappear.
Hi. My name is Emmanuel, and I'm an 8th grader at Alexander Twilight Academy. My question is, when you aren't making repairs to the space station, what do you do up there in space?
Hey, yes, that's a great question. In fact, the repairs that we do for space station, they are really something that we do to make sure that our space vehicle, this amazing machine that we live and work in, stays healthy and, keeps us alive and stays healthy and able to work and support the real work that we want to do up here, which is science, experiments. And so if we're not doing maintenance or we're not doing like cargo operations, like loading and unloading stuff, most of the time we're doing science, performing experiments. And why is it interesting to do experiments up here? You might wonder, we could do experiments on the ground. We have a bunch of laboratories, like specialized, highly specialized laboratories around the world in all scientific disciplines. But the one thing that we have up here that those labs do not have is weightlessness, like we've talked about, microgravity. And that brings to the forefront a number of phenomena, both in the life science, like living organisms, like humans, plants, microorganisms, animals, tissues, cells, all of that, as well as in the physical world, in fluids, in combustion, in materials. There's a bunch of things that either do not happen on the ground or on the ground they're masked by the effects of gravity. So up here, we kind of, in principle, we do have gravity. That's why we're on orbit. But because we are on orbit, we can like switch off the effects of gravity. And then all of that comes to the forefront and we can observe and study it.
Hi, my name's Isabel. I'm in 7th grade and participating in the calculus project. I would like to know, how do you get exercise in space?
So that is a really good question, too. We exercise for about 2.5 hours every day. It is super important that astronauts exercise to prevent things like bone loss and just our general body, from deteriorating, because we're not using our muscles very much as we move around up here. And so we work on one of our devices is called ARED, which is an advanced resistance exercise device. And we have a treadmill and we have a bike. And so for the treadmill, which you can see here, we wear a harness that connects to some springs that holds us down on the treadmill. So it's a little bit different, but it works really well, and we can run, do interval training and things like that. And then we have this ARED device here, which is almost like a universal machine back home, where you can reconfigure it to do all different kinds of tasks like deadlifts or squats or bench press and all that kind of stuff. And it is actually a pretty amazing technology. It uses vacuum tubes, and you're pulling against vacuum in order to create that resistance. So it is a pretty amazing device. And then finally, we have a bicycle. It is a seatless, handlebar-less bicycle, which is a little odd and takes some getting used to. But that is another way for us to get some cardiovascular exercise while we're up here. And so between those three things, we get really good exercise, and in a lot of cases, we return home stronger and more fit than when we got here.
Hi, my name's Gabriel. I'm a junior at Boston University Academy. I'd like to ask, what is the coolest thing you've seen or heard since working at the space station?
Something really cool that I observed almost by chance as we were flying to space station on our vehicle. It's called Freedom, and we were on our way to space station. It was actually supposed to be our sleeping time, but I was awake, and so I kind of snuck up to the small hatch, the small window that is in the forward hatch of our vehicle, and I got to see a burn. A burn is when you need to change your orbit, in our case to get closer to space station, and you turn on the engines. And the engines of our vehicle, they turn on not in a continuous way, but in pulses, like tuk, 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 tuk. And it was amazing because it was night outside, and I could see the plumes of those thrusters with this rhythm, and there's like 4 of them, and they were like creating a very, very beautiful ghostly pattern that I tried to take pictures of it, but it was so faint that it doesn't really show on the pictures that I tried to take, and so it's really only in my memory, and it was really, really amazing.
Hi, my name is Ronaldo, and I'm an 8th grader at Alexander Twilight Academy. I was wondering, what were your first interactions with each other as a crew?
Yeah, that's a really interesting part, and that's one of the most amazing things about being a member of an expedition here on the International Space Station is the personal interactions and the friendships that we make. and they're all a little bit different. Jessica and I were both selected in the same astronaut class. So Jessica Watkins and I were selected in 2017, and so that's where we met, and we went through a whole bunch of our training. We were actually even in a subgroup together, so we did almost all of our astronaut training for 2.5 years. We did it together. Chell and I met when I was an instructor pilot for, long before I got selected as an astronaut. I was an instructor pilot, and so I met him there and developed some friendships there. Samantha, I met on the elevator not long after being assigned to the mission, and I kind of looked at her and went, "You look really familiar. I think we're crewmates now." And so we've gotten to know each other pretty well since then. And then our cosmonaut colleagues down in the Russian segment, at least I haven't met them. I didn't meet them until we were assigned, and they were in the United States doing some training. But like Samantha and Chell have both flown on a Soyuz on previous missions, and so they've had the opportunity to meet some of those cosmonauts as well as some of the others from their previous missions.
Hi, my name is Beatrice. I'm in 7th grade and part of the Calculus project. I would like to know, how do you move in microgravity?
That's a good question. I can try and give you a quick demonstration here, but the nice thing up here is that you're not walking and you just push, and Newton's laws apply, but you don't have all the resistance and stuff that you have down on the Earth. And so if I just put a small little force, I'm just going to drift in the direction that I put that force in. So if I pick my feet up here off this handrail and I just push myself towards Samantha, I'll just start drifting ever so slowly. And then she can stop me with a finger, and of course, then I start rotating and that kind of thing. But you can see how easy it is to move me around. So it's really nice. We just had a cargo vehicle, SpaceX Dragon cargo vehicle, show up, and it had 5,800 pounds of supplies, 5,800 pounds. But up here, they have mass, but they're weightless. And so we're able to pull all that stuff out and just start floating it from one end of the space station to the other. And so I am super, super thankful that we are in microgravity up here, because moving that 5,800 pounds of cargo around without that would be a real challenge and a real workout.
Hi, I'm Chris Kolobos, head of school at BU Academy. On behalf of all the students and BU community members in the audience today, I'd like to thank the members of Crew 4. Thank you for meeting with us today, for answering these students' questions, and for giving us a glimpse into your life and work on the space station. Today's downlink has inspired weeks of space-related learning at BU for hundreds of young people. It has, I'm sure, led some of them to consider careers in science, exploration, and service, following your example. And it has given us an opportunity to celebrate BU's connection to Crew 4 today. Bob, you are leading the way for the next generation of Terriers. We wish you and Crew 4 all the best for the rest of your mission.
Well, thank you so much. It is truly an honor for us to get with you and spend time with you. My Boston ties go really deep. I am just super honored to be able to represent the Terriers and the Boston community up here. It has just been an amazing experience, and so I appreciate all that you are doing. For all the kids that are watching, I mean, this can be you. Don't be afraid to set big dreams and go after them, and just continue reaching for the stars. Have a great day, everybody.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.